Previous videos looked at formulae connecting the angles in a triangle to the sides of the triangle, the sine rule, two forms of the cosine rule, and the area formula. The situations in which you used each of these were if you know a side and an opposite angle, with that pairing, use the sine rule. This ratio, side A over sine of the opposite angle, has a value which is the same as any other similar pairing for other sides and angles. So a pairing, side and opposite angle, sine rule. If you know the two sides and the angle in between, like the hands of a clock and the angle in between, it could either be the cosine rule in this form to work out a missing side, or area formula if it asks you to work out the area, although in the area formula the lettering's a bit different. So for this cosine rule, if you want to work out side A, you need to know angle A. For the area formula, the angle we know is labelled C and the other two sides are A and B. So again, two sides and the angle in between, but lettered differently. Third and final case, if you know all three sides in a triangle and you want to work out a missing angle, this rearranged cosine rule is used. It's important if you want to work out angle A that the side labelled A here in red is on the top line is minus A squared. So you're squaring and adding B and C, but it's minus A squared. So that's the key bit. Side A is opposite angle A. The examples all appeared in previous videos, but I've shortened them here. In this case, if we want to work out this missing side, we have a pairing, angle and opposite side. That tells you sine rule. There's the sine rule. When I want to work out side A, I put it in the top left because the equation's here to solve. So A goes with 43 degrees. The 6 goes with the 55 degrees. That's A over sine 43, 6 over sine 55. That's a pair of ratios. They're equal. Division by sine 43 on the left becomes multiplied by sine 43 on the right. Put that in the calculator. It's rounded off to 5.0. 4 lines of working. This pairing, angle and opposite side, tells you sine rule. Same in the next question. Same triangle. Angle and opposite side, sine rule, working out a missing angle. So we label it as before. We're trying to find out angle A. So we label this angle we're trying to find A, and we actually use the sine rule flipped upside down. These ratios are still equal. I want the unknown to be in the top left because the equation's easier to solve. So that's why it's sine angle A over that 5 and sine 55 over 6. This is division by 5, the other side multiply by 5. Do that in the calculator, don't round. That's what sine A is. To get rid of the sine, inverse sine. Usually you get two answers for this, an acute and an obtuse angle. This is obviously an acute angle, so it's the angle that comes off the calculator, 43 degrees. So that's sine rule because you'll get this opposite pairing. And finding the angle, use the sine rule flipped upside down. Next, if you've got two sides and the angle in between, you could be asked to calculate the area or the size of the opposite side. We want the opposite side here. Two sides and the angle in between indicates the sine rule, the cosine rule. So I've got the cosine rule here, and we label the side we're trying to find small a, so opposites angle A. Put these into the formula. Do that in the calculator. Don't round till the very end. So allow the calculator to do that calculation. Don't forget that's a squared and you've got to square root to get the answer, and only round at the very end. So that's the cosine rule to find a missing side. That same triangle setup can be used to find the area. Two sides and the angle in between, but we label it slightly differently. The formula is a half AB sin C, so C is the angle we know, so we label the angle C. But it is the same setup, so it doesn't matter which are A and B. Put them into the formula, put in a half of 0.5 because it's easier in the calculator, and it gives you the answer, and that's the area in square units. That's the area formula, same setup as the cosine rule. The next case is when we know three sides and want a missing angle, that indicates the rearranged cosine rule. There it is there. Important thing is to label side A correctly. If you want to find angle A, opposite side A. So we want this angle, opposite's the 9. That 9 must replace the A. So that's the triangle labelled. We want to find angle A. The 9 is here, and the red A is minus 9 squared. There's it. Numbers put in. You press the fraction button in the calculator, put in the top line, put in the bottom line, press equals. Answer's negative, it's not a problem. This happens to be 1/3 because the top line was negative 20 and the bottom line 60, but the calculator worked it out. That's what cosine of A is. Inverse cosine gets you the angle, and then you can round it at the very end. So that's three sides to find a missing angle. The key thing is pick the side that's red A here and get that correct. Very easy to make a mistake. And lastly, this is the previous example on the area turned around. The area 14.854 units here. Sides are 6 and 5. Work out this missing angle. Two sides, the angle in between gets you the area. The formula here uses different letterings from the sine or cosine rules. The angle we know is C. There it is in the diagram, angle C we're trying to find. Put these into the formula. There's the area going in A and B. Trying to find angle C. 0.5 times 6 times 5 is 15. Divide both sides here by 15 to isolate sine C. Don't round anything or you knock the answer out. When you inverse sine, you get two answers. You get the acute angle off the calculator, but its supplement, that's the angle taken off 180, is also a possibility because the triangle could be acute angled or obtuse angled. In this case, it's obviously acute angled, so the acute angle is the answer, 82.0 degrees. So that's a deal harder. It's using area formula but turning it around. This worksheet has mixed examples using the formulae. If you download this worksheet using the link in the description, you also have the answers with it. Otherwise, pause the video to do the questions and then pause the video at the answers. That's the answers. Next is the applications of these formulae to some questions, in this case involving a journey, where you're given the distances and the directions using three-figure bearings. This question was used in the cosine rule video, where it worked out the distance. This has got distance and bearing involved. So the first part of the question has actually been a previous video. The second part hasn't. So a ship's travelling 9 kilometres from P to Q, bearing 125 degrees. There's 9 kilometres from P to Q. Bearing clockwise from north, 125 degrees. Then moves from Q to R, 12 kilometres, bearing 260 degrees. There's Q to R, 12 kilometres, 260 degrees clockwise from north. So this is the description, but the diagram shows it. From R, the ship then returns to P. You have to work out the return journey's distance and the bearing. So the distance is RP, line RP, and the bearing is clockwise from north, turning clockwise to line RP. That angle is the bearing of the return journey. That'll be the second part of the question. Now the first part is to work out missing angles in the triangle to give us something to work with. You could use F or Z shapes, that's corresponding alternate angles. For parallel lines, corresponding angles are equal. For parallel lines, alternate angles are equal. We're going to use corresponding angles because it is actually a bit easier here. Angle A and angle A are corresponding with the parallel lines, they're equal. This angle on the other side is its supplement, the supplement of A. It makes up the straight line of 180 degrees. So when I look at the diagram here, on the inside of the F shape, the angles are supplementary, they add up to 180 degrees. So that's 55, because 125 and 55 make up 180, the inside of an F shape with parallel lines. Next, there's a complete turn of 360 degrees here, so that missing angle was 45 to make up the 360. We're trying to work out the length of RP and the angle in here. These two things. First thing will be get the length, that's what we've done in the cosine rule video. And then, once we've got that answer, we'll be able to use that answer to work out the bearing here. So, that's the essentials of the question. Get the distance and bearing of the return journey, that's RP. And we'll declutter this by getting rid of the things we don't need. What we need is the 9 and the 12 for the sides, the 45 degrees in between. Two sides and the angle in between is the cosine rule to work out the opposite side. So we'll label this side A, because I'm trying to calculate this side, I'll call it side A for the cosine rule. Here's the essentials of the diagram. Two sides and the angle in between, cosine rule, there it is. Slot in B, C and angle A. Put it into the calculator, work it through without rounding, and RP comes out at 8.5 kilometres. And that was in the cosine rule video, this part here. Now it's work out the bearing, and that's a bit more difficult. So there's the diagram with the 8.5 we just calculated. I could work out some angles in the triangle using three sides here. The rearranged cosine rule will work out a missing angle. That's a rearranged cosine rule. I could work out this angle here in the bottom left or here at the top. I'm going to work out the angle at the top, that's why I've got north lines in at the top. If I wanted to work out the angle at the bottom left, I'd need to put the north lines in to this right hand corner. So I could work out either angle. I'm going to work out the top one. Could use the cosine rule because I've got all three sides, but I'm going to use the sine rule because I've got a pairing of opposites. So an angle on its opposite side allows the cosine rule. And once I've got this missing angle using the sine rule, so I'm going to use the sine rule, get this missing angle, and then using angles around a point and allied angles with parallel lines, I'm going to work out this bearing. So sine rule, pair of opposites. There's a sine rule. Label the diagram with the angle you're trying to find is A, opposite side A. There's a pair you know, made them, angle B and side B. Slot that into the calculation, sine A over 12, sine 45 over the unrounded previous answer. This is division by 12, multiply both sides by 12. Or if you like, division by 12 becomes multiply by 12. Put that in the calculator. We'll get two answers to this. Calculator will give an acute angle, but it could be the obtuse angle. Because this angle is obviously acute, just take the first answer. So it's 86.5. That's 86.5 degrees in here. And now got the angle inside a triangle. There it is in the diagram. Point here 360 degrees around a point, we can work out the missing angle. There it is. There's a calculation. Then, inside part of an F shape, the allied angles here are supplementary. They make up 180 degrees, so that will enable you to work out this angle down here, the bearing. So, there's a calculation for that. The supplement of 148.5, it's 31.5. So is it, since the angle here, clockwise from north is 31.5, right, it's a three-figure bearing, 031.5 degrees. So that's the bearing worked out. Now there's a worksheet with 4 questions like that and 4 full solutions. If you have downloaded the worksheet, you won't need to listen through the rest, because if someone hasn't got the worksheet, I'm going to go through a few seconds in each slide of the worksheet so they can pause the video. Otherwise, if you get the worksheets from the download, that was the previous exercise with answers. That's this exercise, 4 questions with full solutions. And also there's a set of notes covering all the videos on these formulae: sine rule, cosine rule, area, applications. So if you download the notes and the worksheets, the video's over. I hope you found them useful. Thank you. You haven't the worksheet, there's the first question. There's the second question. Pause the video. Third question. Fourth question. That's the first part of question 1. Second part of question 1. First part of question 2. Second part of question 2. First part of question 3. Second part of question 3. First part of question 4. Second part of question 4. And that's the end of the worksheet.